So once again, just want to say good evening to everybody and welcome to tonight's webinar. I'm Joe Deli Carpini, the Science and Operations Officer, and it's a solo presentation tonight. So I'll take you through a look at the April Fool's Blizzard of 1997, and then as always, we'll also have a weather briefing following the webinar tonight. So I'm sure many of you remember back in 1997, it was fairly warm leading up to the to April 1st, and had a nice few days of springtime weather. And then on March 31st, about this time in the evening, it was raining and starting to change over to snow, and most of the snow fell overnight and ended first thing in the morning on April Fool's Day. So we'll take a look at the snowfall maps and everything in a minute, but first I thought we'd look back at a few pictures, and these are courtesy of the AP, the Boston Globe. These are some pictures in and around Boston. Of course, you can see Fenway Park, a snowblower going to work. I believe the Red Sox that year opened up about a week later, so it didn't affect opening day. But on the bottom two pictures, you can see everyone shoveling out, and the weather did turn milder again right after the storm. So, much of the snow did melt after some time, but certainly a lot to clean up. You can see the snow, up to the car windows, and many were plowed in. Even out in western Massachusetts, Agawam, there was a tractor trailer overturned on the entrance to the Mass Pike, and Springfield and Holyoke also. Quite a bit of snow. You can even see in the top right picture some tree branches were downed as well, and these are courtesy of the Springfield Republican newspaper. And not to be outdone, out in Stockbridge, out in the Berkshires, they also had some cleanup to do. You can see the heavy and wet, sticky nature to the snow sticking to a lot of the trees, and that was a significant concern with power outages too. And on the right, this is in Braintree on I-93 during the height of the storm early in the morning on April 1st. It was definitely a rough go for the rush hour that morning. So just going back, we'll take a look. This was the snow map on the right, and you can see the heaviest snow was concentrated across in that darkest blue area. 20 to 30 inches across much of central eastern Mass, northern Rhode Island, but really widespread 10 to 20 inches in the lighter shade of blue. Obviously lesser amounts along the immediate south coast, the Cape and the islands, but pretty good snowstorm, and especially for late in the season. Worcester topped out at 33 inches, 30 inches up at Blue Hill. Logan Airport, 25.4 inches. Our office in Taunton at the time, 22.3, and even Providence and Hartford over a foot of snow. And just as a note, you can see here, these were not taken at the airport. This was actually during our transition to the automated observing system from the days of having human observers at the airport. So we actually had a couple of years of missing data. Today it's being done by contract weather observers, so we have snowfall records again, but this was in that period where there was a couple of years where we didn't have reliable records for the airports. You can also see some other snow totals. Milford, 36 inches, that's pretty impressive. Newton, 27, so widespread, 2-foot totals in and around greater Boston out into Worcester as well. So certainly a significant storm, especially for so late in the season. So we found this, thanks to our friends at Plymouth State, a nice GOES satellite loop of the storm. And this is an infrared image, so it takes into account the darkness as well. But you can see, you'll see a swirl start to appear off the North Carolina coast. And this is the actual storm here. It moved offshore, but the thing is, we'll show in a few minutes, it strengthened very rapidly, and that helped draw in a lot colder air to help force a change from rain to snow. And the fact that it occurred at night really helps snow accumulate. That's what we look for in late season storms. Snow that falls heavily and snow that falls late at night. That's when we tend to see our best accumulations. And this is just a kind of a freeze frame. This is at about 8:15 in the morning on April 1st. You can see a pretty well-defined storm, the center as well off the mid-Atlantic coast, but you can almost see this almost fire hose of moisture extending from the North Atlantic coming back across into southern New England, and that's what really did it, just a combination of cold air and a lot of Atlantic moisture from a strengthening storm system. So let's go through a series of weather maps here. The first one is on March 29th, so we're a few days ahead of time. And this was if you remember, we actually had a couple of mild days ahead of it. That's why When we had the forecast of snow on April 1st, people thought it was a joke. But we had a southerly flow of milder air getting underway. This was low pressure tracking across the lower Great Lakes. So the wind goes parallel to these isobars. So with a counterclockwise flow around the low pressure system, you can see we have southerly winds. At this point, it's relatively mild for late March. Temperatures are in the mid 40s to start the day, so not bad, and would warm well up into the 50s and 60s during the afternoon that day. On March 30th, that first low had moved offshore, and a second low was now moving through the lower Great Lakes. And this is the storm that it would eventually yield to secondary low development off the Carolina coast, which is one of the way we see our nor'easters. But you can see the day before, this is a look at the high temperatures across the area. And on the 30th, it was 63 in Boston, 54 in Worcester, 61 in Providence, 63 in Hartford, and 66 in Bridgeport. And there was some rain as this low approached the East Coast. So mild, kind of a little bit of spotty rain that day, but this was all setting the stage for what was to come on April 1st. So on 7 a.m. March 31st, you can see we've got this secondary low, which is formed now off the coast of the Carolinas. This would be our primary low here. Still, relatively mild. Temperatures are in the lower 40s with rain falling across much of the region. And you can see from these wind barbs, winds are from the east. So we're getting flow off the ocean, but the ocean is pretty cold. It's 37 degrees here offshore. Remember, we're just starting to warm up our sea surface temperatures from the winter, but strong easterly flow, not uncommon for the early part of spring to kind of have one of these raw days with temperatures upper 30s, low 40s, and a lot of rain. So again, starting the day, it was a rainy day, but later on in the afternoon and especially at night, we'd see a change over to snow. And lo and behold, by 7 a.m. April 1st, you can see the low is now offshore. It's kind of southeast of our 40-70 benchmark, but such a broad circulation around it, as you saw in the satellite pictures, that it still had some influence. By now, notice the wind barbs are out of the north. It's maybe a little hard to see here, but you've got very strong winds out of the north and northeast. That drew down colder air overnight, and as a result, our temperatures now were in the mid to upper 20s, and the heaviest of the snow was starting to wind down across eastern Massachusetts. But you can see it's a cold air mass coming in with this high pressure system. Temperatures are in the low 20s across much of the Great Lakes into upstate New York. So the combination of the two really helped draw colder air into the region, forcing that heavy rain to change over to a heavy and wet snow. So let's take a look aloft. This really tells the story about why the storm strengthened so much and was able to draw in that colder air. So we're going to start high up and we'll kind of work our way down a little bit like we normally do. So we're up at the 300 millibar level. Think of this as the jet stream level. You're close to about 40,000 feet. And you can see there is a bit of a trough here in the white contours, or in other words, a dip in the contours. That's called a trough. And where I've got circled here, you've got some strong jet stream winds coming around the backside of the trough. And what that means is when we have the strongest winds on the backside, it means the trough is strengthening. If they're more on the east side, you can see a little bit here, but as these winds rotate around the east side, the trough will start to lift out. So that's certainly not the case. This is a kind of a strengthening weather system up at about 40,000 feet. And that's going to help provide the energy as this we call shortwave heads toward the coast. So this is at 8 o'clock in the morning on March 30th. We're a couple of days before. Now on the 31st, notice this trough has deepened significantly. There's a lot more amplitude to it. It's centered across the eastern Great Lakes, and you can actually see a low pressure center kind of there over southern Ontario. But note now the most of the strongest winds now are in the base of the trough. So it's this area that is going to help initiate a secondary low off the coast of the Carolinas. And why does that happen? You've got the primary low moving across the Ohio Valley. It transfers that energy as this jet stream energy kind of works its way south. So the combination of this deepening trough and this jet streak are helping to initiate that secondary low off the coast of the Carolinas. Again, this is a pretty typical scenario for when we see kind of nor'easter or a coastal low formation in the wintertime. Now notice by April 1st, the jet streak is kind of moving offshore, but by then you can see, at least in the upper levels, that the low is kind of located well offshore. The system is what we call almost vertically stacked, and you'll notice as I go down in height, as I go through the next few slides, you'll see that low pressure is kind of over the same area. So that means it's kind of slow moving. It's taking its time getting out of the area, but at this point, it's still providing enough lift into the system, which is up to the north. So let's go down a little bit now. This is our 500 millibar level, about 18,000 feet. And if you've been with us before, you know this is our steering level kind of for highs and lows at the surface. Notice we've got kind of the same feature, this upper trough here across southern Canada and the northern plains. This will be our main weather feature as we look for development near the coast. This is on March 30th. As we go to March 31st, again, a similar pattern as we just saw. Now we have a closed off low across southern Ontario, the eastern Great Lakes, and this is providing most of the lift to the east of the Appalachians off the coast of North Carolina, and that's going to help develop our secondary low. And then you can see on April 1st, similar again, you've got this low well offshore at 500 millibars, but kind of in the same area as the one that's above it. So again, this is in a favorable position. It strengthens our coastal low, forces colder air into southern New England, and also starts to slow down the storm as well. So it kind of hangs on a little bit longer than it otherwise would. Now we're looking down, starting to look at some critical temperatures. This is at 850 millibars, or about 5,000 feet. And this is again on April 1st. So now we're just going right to the end. You'll see the low is well offshore. It's kind of in the right-hand side of this image, but this broad circulation was kind of key. Remember on the satellite picture, you could see all that moisture kind of wrapping around the north side of the low and kind of had its sights right on southern New England. This is bringing in plenty of Atlantic moisture. Also colder air, because we have a colder air mass to the north. So it's kind of doing two things, moisture and cold, and that's resulting in a heavy wet snowfall across the region. So let's also look at a few soundings. So again, at the time we had Chatham to look at, and this really shows it very nicely. On March 30th, and I'm going to point you to a couple of things. First of all, the winds aloft and the freezing level. So I've got the freezing level marked here. This is close to about 8,000 feet. So it's pretty warm. This is the freezing level here, the 0 degrees Celsius line, and I've got where it intersects. So this is your freezing level at about 8,000 feet. So this is supportive of rain. There's a lot of warm air below. Any snowflakes that are kind of falling into this layer, it's going to be warm enough for them to melt. It's running into air that's nearly about 50 degrees Fahrenheit. So on March 30th, no surprise, it was warm enough at that point for rain. As we go to March 31st, notice the freezing level was lifted up a bit. Now it's closer to about 10,000 feet. But notice a couple of things. You've got, first of all, with these wind barbs, the winds are broadly from the southwest at all levels. So they're pointing from the southwest. This is bringing in warmer air. It's also bringing in more moisture from the Gulf of Mexico. But notice the number of flags here as we get higher up in the atmosphere above 20,000 feet. This is indicative of a strengthening upper jet. So remember, we had the strongest core of the jet stream to our south across the Carolinas, but still winds were strong enough over our area that we were getting some added lift from the upper jet stream. So a couple of things are going on. You're getting warmer air moving into the region ahead of the storm, and also plenty of moisture and some added contribution from the jet stream itself. Now notice the difference here as we go to April 1st. So we've got our freezing level at about 10,000 feet. Notice how it drops completely, almost down, collapses to the surface. So I'll go back if I can. Here's March 31st, and here's April 1st. So you can see just a complete collapse. And also notice our wind direction has changed significantly. Now we're coming out of the northeast at all levels from the surface, where we have a lot of flags now. So we actually have some strong winds aloft, all the way up to about 35,000 feet. So colder air is coming in at all levels. The freezing level has collapsed to the surface, and no surprise, this sounding is supportive of all snow. Here's the 0 degree line. You can see it's all below freezing at that point. So what about the weather models, and what about the forecasting? Well, back in 1997, yes, we did have several weather models available, not the ones we necessarily have today, but there were three primary models run by the U.S. anyway. So we had one called the NGM, which was the nested grid model, and that debuted in 1987. So in short, the picture shows what a nested grid is. The blue is the large domain, which feeds into this smaller domain over the essentially North America. So a nested grid is having two of these grids in one model, and that's pretty much what we use in most of our models today. But the NGM was the first one to do this. It was a fairly coarse model, so the resolution was about 90 kilometers, meaning each of the grid points were spaced 90 kilometers apart. But for the time, that was the best that we could do with the computing power that we had in the late 90s. This model was eventually phased out in the early 2000s. In favor of the ADA, which is the next model we'll talk about. That was the initial version of today's NAM or the WRF model. It had a resolution that was a little bit better at 80 kilometers, but today we run the NAM at 3 kilometers and 12 kilometers. So you can see the improvements we've made in 25 years. And again, that's thanks to much greater computing power. So the ADA was a little better than the NGM, but not as good as what we have today. And then finally, there was a model called the aviation model. This was just a global model, so think of it as just covering the area in blue. And it had a resolution of 90 kilometers. It's the basis for today's GFS model, which runs at 13 kilometers. So you can see, again, we've increased the resolution quite a bit, which helps us detect more localized weather features. So instead of thinking about things like winter storms and cold fronts, it's able to resolve things like banding in winter storms, areas of heavy rain, lines of thunderstorms. So again, ADA and the aviation model are kind of the forerunners of what we have today. And they performed reasonably well for what we had at the time. Now, if we look back, we actually took a look at some of the forecast discussions leading in the days ahead. Notice there really wasn't much of a discussion of it, going through until almost Saturday. We had some mention the Friday before, but this was really kind of a Monday into Tuesday event. So really at the end of the week before, there wasn't much talk of it. The first part I could find was Saturday afternoon, talking about P-type on Monday here on the lower left, talking about that cutoff low, some talk of, a mix of rain and snow and, maybe trending temperatures down a little bit. But, really as a forecaster, when you get into late March, early April, you're not looking for these big types of storms with, over a foot of snow. Typically, it's a slushy kind of accumulation with a few inches. Again, if you can get the snow to fall at night or fall heavy, you can get some accumulation, but certainly it's on, an outlier to see something like we did with over, a foot, nearly 2 feet of snow. But there was some mention of colder air aloft changing the rain into snow, and as a result of the surface low rapidly strengthening off the coast. So by the Sunday morning, the early morning issuance, note here in what I've highlighted in red, the forecaster is mentioning, there may be at least a couple of inches of snow north and west of Boston Monday evening, but what's worse is the precip should be everywhere, snow everywhere by Monday night, and that aviation model was pointing toward another quarter to half inch of liquid through daybreak. So, they were getting concerned now that we might need a winter storm watch. And keep in mind, we're about 48 hours ahead of this. So, in today's forecast, we have much more lead time because of better modeling. But back then, if you had a couple of days, that was pretty good. So, by Sunday morning, we're a couple of days ahead. They're starting to think, oh, gee, maybe we need to consider a winter storm watch because, roughly a half inch of liquid on a 10-to-1 would be 5 inches of snow, if not a little bit more. So there was some concern starting to show up over that weekend. And then, again, on Sunday afternoon, the day shift, was talking about the initial thought being snow for the whole area, but again, kind of you get into these human factors, thinking, why really against heavy snow? The time of year, the history of the snow season, it was a relatively, not a blockbuster season. And also the strong east to northeast flow, bringing in marine air, which would bring some warming into Boston and Providence. So forecaster was thinking that would keep the temperatures right around freezing, resulting in wet snow that melts on contact. Thus, here we go, talking about limited slushy accumulations, but better accumulations to the north and west of Boston with more of a northeast winds draining some of that colder air down. So, at that point, Sunday afternoon, issuing a winter storm watch for northeast Massachusetts down through northern Rhode Island and points west. And you can see even in Rhode Island, kind of focusing on the traditional hotspots, Woonsocket and Cumberland, the elevated areas, not so much, but more like Foster, Gloucester, Burrowville that are more elevated. So um, definitely starting to see a pattern that, the heaviest snow will be north and west of Boston. Maybe not so much right in the city itself. But by the early morning on Monday, um, you know, again, still seeing that trend, liquid 1 to 3 inches now with, mostly snow and strong winds around 50 knots with a rapidly intensifying low south of Nantucket. So, um, at this point, they had, I believe, put up the blizzard watch Monday morning. Again, we're only about 12 hours out from when the changeover would occur, but back then that was a pretty typical for the lead time that we would see. And then, in fact, here we go. This was the winter storm watch issued Sunday afternoon on the left. You can see it was for essentially Massachusetts, north and west of Boston, northern Connecticut, northwest Rhode Island, and into southwest New Hampshire, which we covered at the time. And just a general statement, 6 inches or more possible in the area. Some snow could start accumulating by late Monday afternoon, but most of the accumulation would be Monday night into Tuesday. And then early Monday morning, the blizzard warnings are going up for parts of the area, which would be later expanded. But the blizzard warnings initially for southern New Hampshire and northeast Massachusetts, kind of the Merrimack Valley region, with winter storm warnings across much of the rest area. But you can see the snow accumulations Monday morning, 10 to 20 inches inland. 6 to 12 inches for Boston and the South Shore. I guess we kind of had to double that by the time it was done, and lesser amounts down to the south near the Cape Cod Canal. But still had the general idea right. Rain transitioning over to snow over New Hampshire, kind of by mid-morning, and eventually during the Monday afternoon time frame, which turned out to be correct, with most of the accumulation occur during the night. And then you can see here, this was Monday afternoon. So we're just about, into the event. Things are starting to take place across the area. We had heavy rain falling to the south. Rain had already changed over to heavy snow in northern Massachusetts. So, at this time, they bumped up the snowfall totals, expanded the blizzard warnings, but pretty much the storm's on top of us. It's Monday afternoon. It's already happening. But the second paragraph is kind of telling you what more the thought that was going on. Um, Cape and Islands having the toughest time changing over, may get a couple of inches of slush there. That's kind of what happened. And again, following that Eta, this was kind of our short-term model back then that was pretty good. Still allowing a loss of a little bit due to warm ground. 3 to 6 inches on the south coast, Hartford, Providence to Boston, 8 to 15, still a little bit underdone. And then the jackpot area that was being forecast was northeast Mass, Worcester County into southwest New Hampshire and northeast Connecticut, northwest Rhode Island with 1 to 2 feet. So there's that word of feet. And just a note, some of you may remember April 6, 1982, that was another significant late season storm. Mentioning, although it's a warmer overall pattern, definitely some resemblance to that, which left up to 2 feet of snow in parts of Cheshire County. So, at this point, we're into the storm, and the warnings are out, but have to do a little bit of adjustment with seeing that the rain has already changed over to a heavy wet snow in northern Mass by Monday afternoon. So, in summary, this was a unusual late season blizzard, brought over 2 feet of snow to parts of southern New England. The cause was the secondary low over the Carolinas, which strengthened rapidly, drew the colder air down at lower levels, which caused the rain change to kind of a heavy, wet, pasty snow. The secondary low was driven by the 500 millibar low that I showed. It cut off over the Great Lakes and pushed offshore. And even though it was well offshore, the broad circulation around it helped bring in Atlantic moisture and colder air into the region. The model forecasts, pretty reasonable for that time. Indicated the potential for accumulating snow a couple of days before, kind of more Friday or Saturday at best. So over that weekend and right up to the storm, the snowfall forecasts were gradually increased, especially once the timing of the changeover became more certain. And really the key was the longer duration of the snow, and most of it falling at night. That, with the late season events, that's what you really want to look for. Heavy, high snowfall rates, and most of the snow falling at night. That tends to help the accumulations to occur. So I'm sure we have plenty of questions. I'm going to go ahead and check our chat box. Just to mention, I've had some questions before. Is anybody who worked that storm still at the office? We've had a lot of retirements, in fact, and people have moved on, so most of them are gone. But we do have. I was at the Northeast River Forecast Center at the time, first winter here in Boston, and I luckily didn't have to go into work that next day, but um, was kind of getting some errands run during that Monday. I remember it was rain, kind of a cold rain, and then it started changing to snow in the afternoon. So just hunkered down for the night and woke up to about 2 feet of snow. So that was kind of a surprise. But one of our forecasters, actually, he manages our IT now. He was working the 3 to 11 shift on Monday, and one of the midnight shift people called in sick. So the other person did make it in. I was coming in from Canton down to Taunton, was able to make it in. It took over an hour. I think it was about an hour and a half for him to get in. But the other person called in sick, so he ended up staying, working a double shift. So he worked from 3 to 11 on Monday to 11 p.m. to 7 a.m. on Tuesday, really the whole brunt of the storm. He drove home Tuesday morning after the snow had stopped. He was living in Rentham at the time. I was able to get home. It took a while. And tried to get into his driveway and had about a 4 foot berm, which was plowed up on his driveway. So luckily someone came by with a plow and helped him out. But after that, he had to get back to the office to come back at 3 o'clock on Tuesday afternoon to work again. So he certainly remembers that. As certainly probably one of the highlights of his career, having to work that long stretch, go home, dig out, and then come right back for his next shift. So with that, let me go take a look at some of the questions. We'll go through those. Yeah, Carrie, 25 years. Um, it seems like it was yesterday. It was crazy. Let's see, Jonathan, one of our snow hounds. Oh, he was on Martha's Vineyard at the time where it was mostly rain. Jonathan, what were you doing there? You should have been over in Newton. But that was a good one. So Samuel has a question: How common are these late season blockbuster storms? They're fairly rare. We've had a lot of people ask, really, what's the latest that we can see accumulating snow? It's not unusual to see it into May. I think some of you may remember May 9th of 1977. That was kind of a more well-known late season storm. How about May 9th of 2020? We even had a little bit of snow then, not much, but at least a coating in some areas with a little bit more in the hills. So really, they are rare, but April of 1982 was another example. We do see them once in a while, and again, it really comes down to the timing. Um, Most of these, we want to see the heaviest snow coming in at night. That really helps it accumulate, as opposed to during the day when you really need those high snowfall rates to get it to stick. And of course, our late season storms also favor areas in the higher elevations. So think Worcester Hills, think northern hills of Rhode Island, northern Connecticut. If you don't have the heavy snowfall rates. If you do get the heavy snowfall rates, you can certainly get accumulating snow big time, even into Boston and Providence. So Carrie also was asking about the April 1986 storm. A little different setup, and maybe that's something we can take a look at as we go through the spring here. If we're looking, I may be able to do a quick review of that if everyone's interested. A little bit different setup, but I'd have to go back and look specifically at what the upper air looked like. So, Carrie, we can certainly put that one on the list. I'm going to take a note, and maybe we'll take a look at that one in April, seeing how our weather patterns kind of calm down a little bit. So thank you. We'll take that as a suggestion and try and take a look at that. Also from Sebastian, mentioning how often do these occur? Is this something that's once in a generation or similar to that? I'd say a little more common than that. If we look at it in the past, we had 1977, 1982, 1997. Maybe every 10 to 20 years is probably not an unreasonable estimate for that. So it's unusual, but I don't think it's as uncommon as we may think. So. We're certainly in the game for snow through April and even into the early part of May in some circumstances. So for the snow lovers out there, don't give up yet. Let's see, from John just asking about the 4-digit numbers in bold print on the weather map. Oh, that's a good question. I'm not sure. I'm going to just go take a quick peek back on the print weather map. Oh, okay. So what you're looking at, those were the latitude and longitude of the low pressure system. So back then, a lot of the maps were sent out by fax, especially to ships at sea. So they would list the lat lon of the low location because it was kind of harder to see it on the map itself. This way, the mariners kind of knew exactly where the low was. Let's see. Also from Sebastian, do modern forecasters still factor history of this year's seasonal snow into their forecasts? It was mentioned in one of the forecast discussions, but it doesn't necessarily seem like there's a correlation between the two, at least to me. Yeah, that's correct. I think that was maybe more of an old rule of thumb. If you've had a late winter, it's now getting into April, so the chances of seeing a big snow aren't there. Yeah, I tend to agree with you. Past performance isn't always indicative of what's going to happen. We saw that in 2015 for sure. We got all of our snow in about 6 weeks. So yeah, I think back then, kind of the climatology was taken a little more into account than it is now. Again, with the advances we have in model forecasts and data sets and things to look at, I think we've got a little bit better signal of seeing some of these unusual events, on the horizon several days before. Whereas back then, if you saw them a couple of days before, you were kind of doing pretty well. Let's see, anything else? I'm not seeing any other comments. I'll just pause here in case there are any more. Looks like that might be about it.